Welcome back, ladies and gentlemen. Today we're talking about classifying real numbers. I'll be honest, unless you're going to get into upper mathematics, there's no real application to understanding the true difference between these. But it is good to know because there are some rules that will tell us kind of common sense. Can I use this operation? Does it make sense to do that? Or how many answers am I going to get? Things like that. So the absolute memorization, have to know like the back of your hand, I don't recommend. But knowing that they're there and knowing that, oh, I can only apply this to fractions, or I can only apply this to non-negative numbers, or I can, things like that is why we want to worry about knowing this. Now over here is kind of a confusing chart. It's the best I can do on a one-screen thing. But the way that I would read this is we have natural numbers. Those are the numbers we can pick up and count. I have one sheet of paper. If I cut it in half, I'd still have one sheet of paper. That's what I'm actually going to write on. So it does not include zero. There's no decimals. There's no fractions. Whatever you count, whatever you have is 1, 2, 3, 4. Zero is not even there. Whole numbers is the exact same thing, except it includes zero. So the idea of whole numbers is there's no decimals, there's no fractions, there's no negatives. It's 0, 1, 2, 3. So the only difference between natural and whole is the number 0. Integers, it starts including negatives. Now, it's still no fractions, no decimals, but it's negative numbers. So from negative infinity to positive infinity, it's the numbers that you can count. And then rational numbers, these numbers include negative numbers, 0, decimals, fractions. If you notice, it starts including more and more types of numbers as we go along this idea. But the rational numbers have to end. What I mean is 0.12 is a rational number because there is nothing after the 2. If the decimal stops, it's a 2. Now, fractions can be a little bit tricky. What you have to do is you have to convert the fraction to a decimal to verify that it is or is not a rational number. Now, all of these numbers are considered real numbers. They're tangible numbers. Now, real doesn't mean, oh, they exist and nothing else does, but what we're looking at is these are, I didn't mark them wrong. This whole thing is actually real down to here. All of these are considered rational numbers. So in other words, all integers, all whole numbers, all natural numbers are considered rational, but not all integers are rational, okay? That's where my brain was. That's why I stopped it. But these are all real numbers. We have irrational, which means the same thing as rational, except these are the ones where the decimal doesn't end. Something like pi, where we've never found an end, it doesn't. Or 1/3, where that 3 is always going to repeat. Those are irrational numbers. So what we're looking at is identifying which type each of these fit into. And really, it takes a calculator to do that. 12, radical. Now, I don't see an end to this decimal. There could be somewhere over here, but if it doesn't show my calculator, I'm going to assume. So this is going to be an irrational number. Now, the easiest way to put that is that it's not a perfect square. However, to be more exact, I would say answer doesn't end, because not all non-perfect squares end. It's really weird. It's pretty close. You can use it as a reason, and you'll still get an A, no problem. All right, now if we remember negative 0.25 with this bar, so it's negative, so it's got to be at least an integer, but it's a decimal, so now I got to step up. So I'm looking for negative, decimal or fraction, and it ends. Well, here's the funny thing. This doesn't end, and that's what the bar says. However, we can write it like it does end. Therefore, we treat it like it does end. So this is actually a rational number. Excuse me, because it's a repeating decimal. And again, even though it doesn't end, and repeating even says that it's not ending, we treat it like it does because we can write it like it does without changing its value. In other words, if I round to end a decimal, I've changed its value, so it doesn't fit into that same category. All right, so here, Pardon me. This is both an integer and a rational number because it's equal to -3. Sorry, I paused there because I was thinking about why would it be both? Because if it's a rational number, so really I'm going to put rational because if it's rational, that means it's every type of number below, in this case, above. And that's because answer is -3, which means it's technically, and I think that's why the book put it, sorry, I'm reading the text, just look at the answers they gave. Because it is an integer, it is -3, and our answer is -3, but because it's a radical and it actually has 2, it's technically irrational. So I'm going to put rational because it's including the idea of a square root. Now 72 over 4, that's going to be equal to 18. And because of that, it's going to be all of these. So I'm just going to put NWIR. And as discussed before, doesn't end. So this is going to be considered irrational. If you have any questions, guys, make sure to email those to me. Stay safe out there. We'll see you next class.